In this lesson, we will be continuing with factorization. Now, the types of factorization we will look at here is difference of squares and then sum and difference of cubes. So difference of squares you've done in grade 9, that's just going to be a revision, but sum and difference of cubes is something brand new to you. Right, so let's start off with the most basic example on difference of squares, and that is when we have x squared minus y squared. So the two things, when you ask to factorize, the two things to identify difference of squares is, okay, it's two terms. Now there's actually three things. There's two terms, and then there is both these terms need to be perfect squares, and then also there has to be a minus between these two terms. And always actually start off by looking for a common factor, and if you don't see any common factor, start by asking yourself, is it difference of squares or trinomial and so on. Okay, so this then, since it's difference of squares, we've got two brackets, and then we simply put in the first bracket we simply put the square root of the first term, and then plus the square root of the second term. And then we do exactly the same in the second bracket, except we have a minus. So we've got x minus y. Now when we FOIL this out, you'll see you'll get back to the original answer. But this is then its factored form. We have two identical brackets, each containing the square root of our two terms, but one has a plus, one has a minus. And it doesn't matter if the minus comes first or the plus comes first. That's also fine. Okay, let's go on to a little more complex sum. This one just has coefficients. So we've got two brackets, and then the square root of this guy is just 3a, and then the plus the square root of this guy is 5b, and then we have identical thing going on in the second bracket, but just with a negative. So 3a plus 5b and 3a minus 5b. Okay, now on to this one. Once again, just have two brackets, and then the square root of that is 9c, plus the square root of this is 7a, and then we have 9c minus 7a. Right, and now we have a fraction. Now a fraction, if I take the square root of a fraction, it's just going to give me, so just take the square root of the top part, the numerator, and then the denominator, so it's just 1 over 9 basically. So if we have our two brackets, then it's just 1 over 9 plus x and 1 over 9 minus x. Okay, now we see that we don't have a perfect, 2 is not a perfect square, neither is 32. Now remember what I said first, always look for a common factor first, and we can see that we can take a 2 out, so we do that first. Here we have 2x squared minus 60. Now what's left in the bracket is difference of squares, since we have two perfect squares that and a negative between them. So we still write down the 2, and then we have our two brackets where we have x plus 4 and x minus 4. Okay, so now if we look at this closely, let's start by identifying our terms. We see there's a term and there's a term. Now there's no common factor that we can take out, and we can see this is a perfect square, and this d minus e, if I have the square of that, I can take the square root of that, is just going to be d minus e. So that is actually also a perfect square. So if I'm going to apply the difference of squares here, we've got 9c plus, and then this, the square root of this will then just be 7d minus e. Okay, like we took the square root here, it just has a 49 in front of it, so basically the square root of that just becomes 7d minus e. And then do exactly the same in the next bracket, 9c, but say minus 7d minus e, and then close the bracket. Now notice that this negative stays negative. That's a constant, okay? We're just taking a square root of a constant. The only signs that change are the ones in between our two terms, one a plus and one a minus. We can just further simplify it by saying, by multiplying out the bracket. So it becomes plus 7d minus 7e. And then for the second bracket, 9c minus 7d plus 7e. Okay, now this one also a bit harder one, although first of all, just remember when you do factorization in general, you always look for a common factor first. So we can see there's clearly no common factor over here. But when we look at the number of terms to identify the type of factorization, we can see it's 4 terms. So it could resemble something like grouping. We could apply grouping here. But what we also notice now, when we say, okay, we're going to apply grouping, we can see when we only focus on the first 2 terms and then the next 2 terms, that's what we do with grouping. We can see this guy actually resembles difference of squares. So let's apply difference of squares there. So we have a perfect square. We've got our 2 brackets there. So we have p plus 2r and p minus 2r. And then plus, now for this part, there's no common factor, so we can just maybe put some brackets around it, like taking out a plus 1. Right, then we see we've got these 2 terms, and this p minus 2r appears in both. So we can take that out as the common factor, and then open the bracket to write down what's left. Now in the first term we've got p plus 2r left, and then in the second one we took out everything, so we're just going to put a placeholder 1. Alright, and then just to simplify this, I'm just going to drop these brackets. So I've got p minus 2r and then p plus 2r plus 1. And that's then my final answer. Okay, in this one, we have something similar than the previous one, where we have, okay, no common factor, first of all. But then focusing on this part, we can identify difference of squares here. The more sums of this you practice, the more obviously it will become obvious to you, or you can identify it easier. You'll see it easier because you'll also get used to the numbers 1, 4, 25, 16. Those are the perfect squares. Right, so difference of squares here, we have our 2 brackets, and then we have 5a plus 4 and 5a minus 4. Okay, taking the square root there, and plus and minus. Then plus this part, 5a minus 4 and a minus 2. Alright, so now we see that in both of these terms, because this is one term, this is one term, we can see 5a minus 4 occurring. So taking that out as a common factor, 5a minus 4, this is 5, and then what's left is this 5a plus 4 plus a minus 2. Okay, now we can just further simplify this by taking out, well, there's nothing to multiply in the brackets, but we can add the like terms basically. So 5a minus 4, and then here we have 5a plus a is 6a, and 4 minus 2 is plus 2. Okay, there's our final answer. Okay, so that was then difference of squares. Now let's look at sum and difference of cubes. Alright, now this is once again the sum and difference of cubes, but in its most simplest form. And as you can see, like the difference of squares, it's got 2 terms, alright, where the first one is a perfect cube, or both of these terms are perfect cubes. Something that's different is this sign can be either a plus or a minus. Now I'm just going to go ahead and do the general form for when you factorize. After you've identified this as a sum and difference of cubes, then this is the steps that you take to put it in its factorized form. So we'll have a small bracket and we'll have a bigger bracket. So for this, so there's 2 terms here, a term here and a term here, and there's 3 terms in this bracket. So for the first term, you just simply take the cube root here, so that's just x. Then you take the same sign, that becomes plus. Then you take the cube root there, which is y. Okay, now at this point, we can actually forget about this top part. You can actually now just focus on these two. Now to get this term over here, we just take this x and we square it. So that's x squared. Okay. Then to get the sign here, it's the opposite sign than this sign. So this becomes a minus. So if this was a minus, this becomes a plus. If this is a plus, it's a minus. Then we multiply them together. So we have xy. So this is where we just multiply both of these together to get the middle term. And then always a plus. And then to get the last term, we just square the y. So that is y squared. And once again, you can actually FOIL this out or multiply this out, and you'll see that you'll get back to that answer. So I'm just going to go through these steps again, but with the minus, just a bit faster. So we have two brackets, one a big one and one a small one. And then we take the cube root there, so that's just x, the same sign, minus, cube root there, y. Okay, so square the first one to get this first term here. Opposite sign becomes a plus. Then multiply together, xy, always a plus, and then square the last one, y squared. Right, and that's your answer then. Okay, now to look at a bit more complicated one, and this one only just have a coefficient in front of the variable. So these coefficients are perfect cubes. We can see this whole term is a perfect cube. If I take the cube root of 125 a cubed, it just becomes 5a. All right, and similarly for 8a b cubed, we just have 2b. Okay, so I open my two brackets, and in the first one we've got 5a, because that's the cube root of this, the same sign, and the cube root of that is 2b. And then we square this 5a. Now once again, if I square that, the square goes to both the bases, so that becomes 25a squared. So this is 25a squared. Opposite sign, minus, multiply together, that gives me 10ab, always a plus, and square the last one is 4b squared. Right, now moving on, this one is quite simple again. So we have our two brackets, and in the first one I have the cube root of 64 is just 4, same sign, and cube root of x cubed is x. Square the first one is 16, then opposite sign is plus, multiply together is 4x, always a plus, and square the last one is x squared. Okay, moving on to this one, let's just apply the same. Here we've got our two brackets, and we've got the cube root of that one is 3x, same sign. Cube root of that one is 2y. Then we square the first one, so we get 9x squared. Then the opposite sign is a plus. I multiply them together and I get 6xy, always a plus, and square the last one, which is 4y squared. And then we have some fractions. Now once again, if I take the cube root of a fraction, so I've just got x cubed over 64, and then you just take the cube root of the top one and the cube root of the bottom one. So this would just leave us with x over 4. All right, now opening our brackets, we have x over 4, so that's just the cube root of that, same sign. Cube root of this is then 1 over 2, and then square the first one. Now once again, if I square, let's say I square x over 4, the 2 goes to both the bases, so this just becomes x squared over 16. Okay, so this is then x squared over 16. Opposite sign is a plus, multiply together is x over 8, and then always a plus, and then square the last one is 1 over 4, and there you have it. Right, so that's it for this lesson, and then you can do your homework.